Good, we started. Okay. So, after this... Ben, do you mind opening the door, please? Ben, what happened to you? Oh, Ben, for your first physics class. That's so sad. Well, anyways, I'm only starting now. You got pen and paper? Pen and paper? Yep. Okay. It always takes the computer a while to start after a break because it's been off for 2 weeks. So this is the first time I've used it in class. So it takes a minute to get back to normal. Okay. You know, because it's doing updates and all this stuff. Okay. So what did you do in chemistry yesterday?
Yeah.
What did you do?
I learned the table, the element table.
Oh, okay, good, yeah. 1 or 2 classes?
I think only one, because usually we have the activity for a new student.
Yeah, okay, yeah. Right, so we're going to start this morning. First lesson. So, remember I said yesterday, Tuesday? The first topic we're doing is mechanics. And I think we have quite a lot to do in mechanics. I said maybe 5 weeks. Because you can see here we have, I can show you, I have to do quite a lot, like 25 lessons, 25 topics. So mechanics is pretty big. Okay, so the first thing we're looking at is dimensions and units. If you can write that name down, dimensions and units is what we're starting with. Of course, the date is wrong, don't worry about that. Alright, dimensions and units. I think these are new words for you. Do either of you know these words? Dimension, unit? Yeah? What do you think, Ben?
I know the second.
Unit?
Yeah.
What's a unit? Can you explain?
Like, I can, for example, like M.
Yeah, like which one?
M or S. Yeah, like this.
Yeah, like S. S is an example of a unit. What else? Do you know any more units?
V.
V, yeah. Anything else?
Lots.
Lots of them, yeah. Yeah, what would I use to measure
Force.
You could measure, yeah, force, yeah. What unit is for force? It's an N. What's that called? N.
NG.
Newton. Yeah. Anyways, we'll have a look now. So, let's see, continue. Oh, come on, wake up. You can see it, so slow for the first day, always. There we go. Right, so these are the things we'll have a look at, don't worry. Right, so exactly what is a unit? So a unit is a system used to measure a quantity. Now, when I have something up here, you don't have to write everything, okay? You just maybe write, key ideas. So for example, here the key idea is a unit is a system to measure a quantity. To measure time, you use seconds. To measure force, you use newtons. So yeah, maybe you just want to write unit is a system to measure quantities. I think that's enough. Now, there are what we call fundamental dimensions. These are like basic dimensions. There's 3 of them. There's length, mass, and time. These are fundamental. Length, mass, and time. So length, you know, is like this.
Yeah.
Mass is, you know, how heavy, and of course, you know, time.
Yeah.
These are the fundamental, like the basic dimensions. So I think you could write length, mass, time equals fundamental dimensions. Do you know this word fundamental? It means like basic.
Yeah.
You know, you know. Okay, so for example, the meter. What do you use to measure the meter? The meter measures what? It measures length. Yeah. And other dimensions exist, and you can make them from these three fundamental dimensions. So, for example, area. Area is length squared. So area is like this, and that is length squared. You know this, I think. Yeah. The size of the unit is called the magnitude. So if I say what is the magnitude, that means what's the size, how much, how big, you know. So magnitude, you'll need this word, magnitude. Is this a new word, Ben, or do you know this word, magnitude?
I don't know.
It's a new word.
Yeah.
And for you, Go? New word? Yeah, okay. So if I said, what is the magnitude of the mass? It means, you know, how many kilograms. I said, what's the magnitude of the length? Or whatever, anyways. It's how big, the size. Okay. So in Ireland and in China, we use what's called the international system of units, called the metric system. This is an international system. It's used in every country except for two. In some countries, they don't use this system. They use the old system, feet, pounds. Which country is this that uses the old system? You know the old system, like feet, inches, pounds? Who uses that still? You don't know? You don't use this in China, of course. You use kilograms, seconds, meters, yeah. But some countries use the old one, pounds, feet, ounces, inches. Who's that? You don't know who does that still?
UK.
In UK is interesting, they use both. But there's one country that only uses the old system, it's America. So in America they don't use kilometers or kilograms, they only use miles and feet. So the UK is strange because they use both. You know. So for example in the UK, for driving, they use miles. Okay, so there are, it's used everywhere except America. And there's 7 basic units, and you actually know some of the 7. So the first one we'll have is the meter. And what does the meter measure? It measures length. Okay. Now, just to be clear with the English, okay? The meter is the unit, and the length is the dimension. Okay? So we say meter is the unit, and length is the dimension. So the dimension is what the unit measures. Do you understand what I'm saying? So we don't say length is the unit, we say meter is the unit. And we don't say meter is the dimension, we say length is the dimension. You understand the difference? Maybe. The difference is this. In America, they say dimension is length, and we say dimension is length. But they don't say the unit is meter. What do they say? The unit is what? What do they use in America? Miles, maybe. The unit is miles. You know. So this is always the same, but this can be different in different countries, the unit. Right? Did China How long has China been using the international system, do you know? For all your life?
We
Yeah.
use meter.
Yeah. You only ever remember using meter.
Yeah.
Yeah. When I was in elementary school, we were still learning both. We still had to learn meter and the old system. But then a few years ago, maybe 10 years ago, we finished changing everything to the new system. Because maybe 15 years ago, maybe 20 years ago, my goodness, 20 years ago, we were still using miles per hour in the roads. But then one day, all the signs were changed to kilometers. Okay, meter is one. What else is there? You know some more units. What else? Kilogram is one, yeah. Yeah, what else? So we have kilogram. What about the time? Seconds, yeah. So the kilogram, and what does kilogram measure? It measures what we call mass, yeah. Okay, so if you can write this one down too. Good, okay. You said the next one, Gav, was seconds, and what does seconds measure? Time, yeah. So seconds, and that measures time. Okay, now it gets harder. Do we know any more? Any more? There's 7, we have 3. There's 4 more. 4 more, yeah. These are the ones everybody knows. Yeah. So the next one's now something we call the ampere, and that's used for measuring what we call electrical current. For the electricity. Okay, and we'll study this one later. So this is called the ampere. Have you heard of this one before?
Yes.
Or is this, you've heard of this one? Yeah. Do you have your phone charger with you? Yeah, take out your phone charger. I'll show you. It says it on the plug.
I will have the USB.
Oh, then that's no good. Have you got the one for the wall?
No.
Oh, okay, all right. Let's see. Here, maybe I'll just take this out and hope it's okay. Where does it say it? Oh, maybe it says it on this part. Yeah, I can see it. See, here, you can barely see it. It's 1.1 amp.
Yeah.
So it's on everything. If you look at your phone charger, your phone charger will probably be the same, like 1 amp, something small. Okay, next one. Next one is the Kelvin. Have you heard of Kelvin? No. Okay. Kelvin? No. Kelvin measures temperature.
Oh.
Yeah.
Yeah.
Now there's another one that measures temperature as well, that we also can use. Do you know what that's called?
More like degree, like C.
Yeah. What's C? C is Celsius. But we try to use Kelvin instead, and we'll study this later. What did they use in America, do you know? Instead of C?
Little Chinese.
Yeah. You know it in Chinese? What's it in Chinese? Oh yeah, no, it's totally different. Fahrenheit, F. Okay, next one. Next one is mole. Now, have you ever seen this one before? Mole.
No.
This is new.
No.
Have you studied chemistry before?
Yeah.
You did chemistry in high school. Did you do chemistry in high school? Mole is from chemistry. It measures how much you have. You know, like you can have 1 mole of oxygen, 2 moles of hydrogen. You know, 1 mole of O2. You know, like it measures how much you have. It measures amount. How much. Maybe you might remember something like 1 mole of C12. You know C12? Carbon 12, C12. 1 mole of C12 is 12 grams.
Mole.
Yeah.
Oh, okay.
You know it now, yeah. Maybe you say it differently in Chinese.
Similar.
Yeah, what is it? What do you say in Chinese?
More.
You know this?
More.
No, okay. Okay, this is new for you then, but you've heard this before. And the last one, now this I don't think you heard, candela. No. Candela, well, what word is this like? Is there any word in English that looks like this? Candela. Do you know, can you think of any word like this that looks like this? Candle. You know candle?
Yeah, I know.
What's a candle?
Like a lie.
Like a light. Yeah. So what do you think this measures then?
Lie.
Yeah, it measures how bright something is. What we call the luminous intensity. That means how bright.
Oh.
We measure it in candelas. Yeah. So, yeah, these are the 7 basic units. Two of them are named after people. Which 2 are people's names here?
And
Amper, very good, yeah. Who's the other one? Calvin, very good, okay. Alright, can I continue? Do you have this? 1 sec, yeah. Yep? Okay. Now, quantities of the same dimension can be compared or equated. So what I mean is, and I think you know this, you can say 3 meters is bigger than 2 meters. But can you say 3 seconds is bigger than 2 meters? No, because they're different dimensions.
Yeah.
So, if you want to compare, they have to be the same dimension. You know this, I think. If you want to add or subtract, multiply or divide, you can do this at the same dimension. So you can say 1 meter plus 1 meter, 1 meter times 1 meter, and so on. Quantities of different dimension cannot be added or subtracted. So you can't say 2 meters plus 3 seconds. You can't do that. And quantities of different dimensions can be multiplied or divided. So for example, you can do something like this. You can say 1 meter plus 1 meter. That's fine. You can say 1 meter minus 1 meter. That's fine. You cannot say 1 meter plus 1 second. That's no. But could you say 1 meter multiply 1 second? You can. That would be 1 meter second. And could you say 1 meter divide 1 second? You can. That would be 1 meter per second.
Yeah.
Okay. Now I think you know this.
Yeah.
You know this. So you don't need to write this down. I think you know this.
Yeah.
Okay. So let's practice some questions together. So which ones are right and which ones are wrong? Which ones are valid and which ones are invalid? So the first one, 5 meters plus 2 meters equals blank. Is that right or wrong? Can you do this or not? You can't do this. Okay, so this is correct. Okay, so this is fine. 5 meters is bigger than 2 meters. Is that okay? Yep. 2 hours is bigger than 1 kilogram.
No.
X equals 3 kilograms over 2 meters cubed.
Yeah.
That's okay. 5 meters plus 2 kilograms? No.
No.
5 meters times 2 kilograms?
Yes.
Yes, that's okay. Good, okay. So can you just write these examples down and just write beside them right, wrong, you know, just for examples in your book. Yeah. So you could write 5 meters plus 2 meters, correct. You can just write down it's right or it's not right, you know, like, yeah, like that, yeah. Good, okay. You have all that? Yep. Now, what are the dimensions of each of the following? And note that x has a dimension of length, m has a dimension of mass. And the way we write that is we use these brackets. So we say the dimension of x is length, and this means dimension of m is mass. Okay, so what is the dimension of w? So let's have a look at this one together. So you have w equals x plus y plus z, and you know that the dimension of x is length. So this is a length. So what is this? Can you know it?
Length.
No.
Yeah, but why?
Because length only can put
Plus. Yeah, very good. So these must be length also. So then this must be length. Okay, good. All right, I think you have the idea. So I will let you do these by yourself now for 1 minute.
Okay.
Try to do these ones now. So you did the first one. So now, by the way, the x and y here is the same as here.
Oh.
So you know that this is length and this is length. So you know. Oh, I see. You're going to have one book for notes and one book for questions.
Draft.
Graph?
Draft.
Oh, draft. Okay. Yeah, so you can write that, Ben, as L squared or L cubed. You know what I mean? Yeah. Yeah, in the last one, you know also that
Yeah.
dimension of m is mass. You think you're finished, Gail? Finished yet? Which one are you doing, Ben? Are you doing this one? Last one? So, what's the second one here, Ben? Tell me the second one. Dimension of A is... Yeah.
Oh,
Yeah, you wrote it down. What did you get?
the same length.
Length, yeah. Length.
I mean the x equal y.
No. Well, yeah, I suppose they're both length. If you have A equals xy, this is length, and this one is length.
Yeah.
So that means area, A is length squared.
Oh, what is length too?
Well, I'll give you an example.
That means the two lengths no equals.
Yeah, well, yeah, they're not the same, but they're both lengths, and they both use meters.
Okay.
So it means if A equals xy, then this is a length squared. Now, I'm not saying this. I'm just saying they have the same dimension. They measure the same type of thing.
Okay.
So that means it would be in meter squared here.
Okay.
You get the idea?
Yeah.
What would this one be then? V equals xyz. What's the dimension here? What you got there?
3.
Yeah, what's L3 called?
I,
Yeah. What's that called? Go on, try. L. What do you say? Do you know, Ben?
it's not like cube.
Yeah, cubed. Here. Let me wait, let me give you this. This one is x squared, okay? This one here is x cubed. Do you know this one? Nice try, but it's actually just x power 4. Yeah, and this is x power n. Yeah, you should remember this is useful. Okay, so what did we say this one was now? V is measuring what? L cubed. Yeah? Okay, lastly, this one. What's the dimension here? Well, what's the dimension here? So, what have we got?
This density.
This is density, yeah? This is density, and what's its dimension?
How much?
Oh, I mean, what is the letters here? So what is the dimension of M? M measures mass. Okay. And what did we say V was? No, the V is the same as this V.
Yeah.
Yeah. So length cubed. So this density is mass over length cubed. This is mass over length cubed. That's its dimension. Yeah, so let me write these down. So the first one, the dimension of W, we said was length. The dimension of A, we said is length squared. The dimension of V, we said is length cubed. And the dimension of density, we said is mass over length cubed. Okay. Now the next thing I want to do is what are the units for them. So we'll do that one together. So if W is a length, what unit do we use? Meter.
Yeah.
If A is a length squared, we use
Meter.
meter squared. Okay, next.
Meter cubed.
Meter cubed. And this one? Well, what unit is mass? Kilogram over meter cubed. Now, just so you know, guys, the way you read this is you say, kilogram per meter cubed is how you read it. Yeah, per. Okay. Yeah. Okay, so I think you should write this down. So that's the dimension, and that's the unit. Yeah? Making sense? And Ben, you do actually need to write these little brackets. So just so you're clear, if I write this,
Okay.
this means dimension of f is what?
Oh.
That's what that means. So when I write this, I'm saying what is the dimension of w? Its length.
Okay.
Good? Yeah? Got it? Okay, let's continue. Right, so you said this word already, Ben, as density, and the letter we use is this.
Yeah.
What letter is this?
Pardon.
What letter is this?
Right.
Yeah, what letter?
It's P.
From not P, no? No?
No.
Yeah. It's not a P, is it?
Row.
Very good, Rho. It's a Greek letter.
That's great.
Greek, yeah. And the name of it is Rho.
Row.
Yeah. How did you know that?
That's what we
We
call
learned.
it in high school.
It's the same.
Yeah.
Yeah. In China, you call it Rho as well.
It's similar.
Similar. Good. So it measures mass per unit volume. So we have the formula, it's mass over volume. And we worked out its dimension is m over L cubed. But you can also write it like this, ml minus 3. And the units are kilograms per meter cubed, or we can write as kgm power minus 3. Now, which did you use in China? Did you write it like this or like this? You know, do you use the slash or the power? Slash? Ah,
Both of them.
both of them, yeah. For this course, we and I will try not to use the slash. It's normal nowadays to use the minus, okay? So try to remember to write it like this and like this.
Okay.
All right, so this is a definition, so you need to write all of this down. Now, you don't, no, actually you do. Yeah, write the whole thing down.
Slash means
Per.
per.
Yeah. So like, for example, we don't like to write this anymore. We prefer to write this.
Okay.
Yeah. Okay, can you write this definition down? First definition of density. This blue box. You got all of that? Yeah? Okay. You got that, Ben? You need a minute?
Okay.
Is okay?
Yeah.
Now, here's an example. What is the density of water if 1 litre of water has a mass of 1 kilogram and 1,000 litres is a metre cubed? Okay, so let's work this out together. So we want the density of water. That's the mass of the water over the volume of the water. And do you want to use 1 kilogram or 1,000 kilograms? It doesn't matter, you can use either. So for example, if you use 1 kilogram, then you have 1 kilogram over 1 litre. But here's the problem. The problem is litre is not a unit, not a good unit we use. We use metre. So we need to change this. Well, if you remember, we said 1,000 litres equals 1 metre cubed. So what is 1 litre? That would be 0.001 metre cubed. Because we have 1,000 litres is 1 metre cubed. Yeah? So 1 litre is 0.001 metre cubed. So this equals 1,000 kilograms per metre cubed. Now you could do it like this, or you could do it like this. Density of water is 1,000 kilograms, and 1,000 kilograms is 1,000 litres. But we said 1,000 litres is 1 metre cubed. So you get the same answer. 1,000 kilograms per metre cubed. So it doesn't matter if you have a little water or if you have a lot of water. This is the same for both. Yeah. So I don't think you need to write that down. But I think maybe you should write down that 1,000 litres is 1 metre cubed. Did you know this or not? You don't look like you know it.
Liter and meter, I don't know, meter is...
Sure. Sure.
Liter I know, meter.
Yeah. You know meter.
M like...
Yeah, like meter.
Okay.
Yeah.
Oh.
Yeah. Did you know this? 1,000 litres equals 1 metre cubed? Did you know this? You learned that before, yeah. Okay, continuing. So, now, we can use prefixes to make units bigger or smaller. So, for example, 1 kilogram is 1,000 grams. 1 kilometre is 1,000 metres. And 100 centimetres is 1 metre. These are called prefixes, the kilo and the centi. So we have to look at what are the common prefixes. So the first one we'll do is giga. Now, giga, do you know how big giga is? Well, firstly, do you know what letter giga is? Giga is a G. Do you know how big it is? How many it is? A kilo is 1,000. Do you know how big a giga is? How many zeros? Let's see. It's 10 power 9. That's how big a giga is. What's that? That is... Does anyone know the English for this number? 9 zeros. Billion. It's a billion. Okay. Alright, write this first one down. That's giga. G. 10 9. 10 power 9. You know giga from computers. Gigabyte.
8
Yeah, 8 gigabytes, yeah. Like on your iPhone, you know? How big is it? Yeah, how big's an iPhone? Like 32 gig? Okay, good. Samsung then?
No, I use Huawei.
Oh yeah, Huawei, yeah, I know them. They're very cheap. It's good. Better than iPhone.
Yeah.
Yes.
That's
Yeah. Okay. What do you have?
iPhone.
iPhone. Wait, did you see my phone? So amazing. Look at this. Amazing, right? This is the new iPhone 10. Right, giga. Now, what's under giga? What's smaller than giga? What's the next one?
MB.
Well, not B, not B. Just the M. Mega. How big is it? How big?
Billion.
No. We said this is billion.
Million.
Million. Yeah, million. 10-6. Right, now, what is next? If we keep getting smaller, what's the next one?
KB. K.
K, what's that called? Kilo.
Kilo.
And how big is it?
1,000.
1,000.
Kilo.
Kilo, yeah. Yeah, kilometer, kilogram.
Yeah.
Okay, now we get into the smaller ones. Centai. What letter is centai? It's C. How big is it?
Maybe 1.
No, not 1. It's 10 minus 2. 10 power minus 2. It's 0.01. Yeah?
How to say? 10?
Yeah, I was going to this is 10 power minus 2.
10
Power. Minus 2.
Minus 2.
Yeah. How do you read this number? 0.01, but it has a name. You know, like this is billion, this is million, this is thousand. What's this one called? You might know. It's called hundred. 100. Yeah.
100.
Yeah. Yeah? You don't know this one? So for example, like this. What do you call this? This is called a tenth. And this one here?
Oh.
100.
Yeah.
And this one here, what would you say that is?
1,000.
Yeah. So a centai is 100. Yeah. Okay. Right. What's the next one? What's after centai? What's smaller than centai? What's the next one down? Do you know? No. Think about your ruler. Do you have a ruler?
Ruler.
Yeah. Do you have a ruler? You know.
No.
No. Okay. What's smaller than centai? Yeah. What's that called? Okay. It's milli. It's m. And it's 10 minus 3. And that's 1,000. Yeah?
Yeah.
Okay. Now, next. Micro. What letter is micro? Do you know it? The letter? It's not M.
I don't.
What's this letter?
Yeah.
Yeah. What is it?
10.
Oh, it's 10 minus 6.
Yeah.
But what's this letter called? It's a Greek letter. I thought you knew your Greek letters, Ben. You knew rho. Do you know this one?
I don't know how to.
How to say it? Do you know this one? It's called mu. Mu. Mu.
Oh, Mu.
Mu. Yep.
It's too far. They graduated 2017.
Too long ago, huh?
Yeah.
Yeah. Mu. Yeah. Okay, one more to do. The next one. What's after mu? One more. Do you know? Last one. It's called nano. It's n, and it's 10 minus power minus 9. Yeah. You knew this one? You saw this before?
Yeah.
Long time ago.
Yeah.
So these are all called prefixes. Prefixes, yeah. Okay, do you have them all? They're important. You must know these for the course, for the exam. Yeah, alright, so this is an important example of how to use units and prefixes. So for this question here, I'll do this one with you. The question is, convert 50 kilometers per hour into meters per second first, and then miles per hour. So first we'll do into meters per second. That's the first one. So we want to change kilometers per hour into meters per second. Okay, so let's do this one. 50 kilometers per hour. We say that's equal to 50 kilometers over hours. Okay. Then what we'll do, you look here and you remember that K means 1,000. So that is 50 times 1,000 meters over, and then hour is 3,600 seconds. So we just need to put this in on the calculator, and we have the answer then. Do you have your calculator? I have one here. Hang on.
I got the one
You got it.
Casio, but it's
Great.
not totally same. But that's English. That's the one.
Let's see it.
This one.
I think that should be fine.
It's
Does it have?
totally-
How do you open?
I don't know. Under my arm.
Yeah, but how do you open take the lid off?
No idea.
Oh, here we go. Oh, yeah, okay. Your one is okay as well. So, can you type this in? Do you know how to use these? No?
Yeah.
Yes.
Yeah.
So look, I have one here. So we have this button here. You see this button? Fraction.
Yeah.
Yeah. 50 times 1,000. Oops. Over 3,600. So you can use this here to move. You got this, Ben?
Yeah.
Yeah. Go.
Yeah. I
You have
tried
trouble? Let's see.
yesterday.
Oh, this calculator is not as nice. Yeah, it's a bit ugly. So maybe you should use these bracket. And then on the top, what is it? You can do 50 times 1,000, close bracket, over bracket.
Do I look like this?
Yeah, it's ugly. Oh, 13 and 8/9. Ah, this is ugly. Where'd you get this?
It isn't 27.
27. Where'd you get yours?
11.
11 euros.
In Tesco.
How much?
11.
11. I think he got the better one. Can you change this?
I don't know.
Yeah.
I just bought it yesterday.
Yeah. Only 11 euros.
Yeah.
Which Tesco? City Centre?
The biggest.
Good deal. Good deal.
I looking for the.
You look everywhere.
Yeah.
This one's okay, but it's not as nice as that one. Because, you see, now you have this.
But what's that mean?
This means, here, I'll write here. It means this. Go. It's like this.
Coming.
13 and 8/9. That's what it means.
Okay, but
Yeah, that's a problem, isn't it? Now, hang on, let's see. You might be able to change this. Where's... Yeah, so maybe if instead we use, instead of that, how do I delete? Whoops. No. Okay, that's better. So don't use that button, use this button.
okay.
Then you can get the answer like this, so now it's okay. 13.88. And then you see on his calculator, if you press the answer, he gives it like this.
Okay.
But you can press this button to change it to decimal. 13 point.
Oh, use this.
This is for decimal.
Oh.
So you can switch the form.
Oh.
But I don't think you have this button, this SD button. I don't see it.
What's that for?
For changing the form.
Okay.
You see, you can write it differently. Yeah. Do you have SD? No, I don't see it. Okay. So this is okay. So just remember, you can use this button, but maybe you should stick to using this one. And also, you'll need to use brackets here. So, like for example, maybe 125 divide whatever 22. It's okay. Yeah, it's okay. It's all right. Yeah. Okay. So you can see on my calculator, the Casio, this one here. If I press equals, I get the answer like this.
Yeah.
But I want it like that. Okay. Now, for this course, you must give your answer to 3 significant figures. What I mean is you give the answer as 13.9.
Yeah.
Yeah, 13.9. You round it up. Yeah? So, because this is an 8.
Yeah.
Okay, can you write this down? And we'll do another example. So this is an example. Yeah?
Oh.
Yes, if you can write this down.
Like
Yeah. In your notebook. Why do you look confused?
HR means
Hour. Mhm.
Oh, I mean R is
Yeah?
harder.
Utter? No. HR means hour,
Okay.
which means 3,600 seconds.
Converter into means change.
Convert means change.
Convert means change.
What? You don't have a calculator from China, right? No calculators in China.
I didn't take it.
Yeah. You're not allowed?
I didn't notice I will use this.
Mm-hmm. But I mean, in Chinese schools, they don't use calculators, right?
Teacher like to
We don't allow us.
They don't allow it, yeah.
calculate by myself.
Oh, that's so
In the
so
brain.
painful.
Yeah.
Yeah. Okay, you wrote this down? Yeah? You
Yeah.
got this? So the next one now is, we said, convert 50 kilometers per hour into miles per hour. Miles per hour, mph. And you need to... Yeah, this is the old system. This is the old system, what they used in America, miles per hour.
So, what's the prefix for mile?
Well, yeah, what we have is a mile is 1.61 kilometers.
Okay.
So 1 mile is 1.61 kilometers. Okay, so let's do this together. 50 kilometers per hour equals 50 kilometers over hour. Now, let's look at this together. So, we want to get miles per hour. Miles per hour. So I'm happy that we have hour here, because we want hour. But do we want kilometer? No, we want miles. We want miles. Okay? So we need to change this one.
Yeah.
Now, how do we change it? Well, we said 1.61 kilometers is 1 mile. So, here's my trick. If I put 1.61 here and 1.61 here, what has this become? What is this now? It's a mile.
Yeah.
So, this is 50 over 1.61 miles over hours. So, in other words, it's the mph we wanted, miles per hour.
P.
Per.
Oh.
Miles per hour, yeah. So, what did I say? 50 divided by 1.61. 31, is it? Yeah. 31.1? Yeah. 31.1. Okay. If you can write that down, we'll do another one. Yep. Okay. Okay, so we have 2 more to do. I want you to convert 50 centimeter squared into meter squared. Now, please watch carefully because so many students get this wrong.
Yeah, yesterday.
Yes, it's very common to get this wrong. Now, before I start, I want you to know something. Yeah?
Yeah, you can.
In maths class, look, in maths class, if you write this, you do not mean this. Right? They're different. Okay? But in prefixes, if you write this, you actually do mean this. You actually do mean it. So here, let's begin. 50 centimeters squared, that's equal to 50 centimeters squared, like that. True? Okay. So that's equal to 50 centi squared meter squared. That's equal to 50 0.01 squared meter squared. Because remember we said centi is this. Yeah. So that's 50 times 0.0001 times meter squared. 1, 2, 3, 4, 0.005 meter squared. Okay. I would say 50% of students get this wrong in the exam. I think it's this step here and then this step here can be confusing. Is it okay? Ben, what do you think? Is it okay or not?
Yeah.
Are you sure? Cal, it's okay?
Yeah, I'm thinking another way, just when.
Oh yeah, sorry. I should say this. I don't like the other way. I don't like it. Because personal reasons. But I know there's other ways to do this. I don't like them. I think they're a mistake. it is easy to get it wrong. I think it's difficult. I don't like the other way. I would like you to do it this way. And the reason I like this is because it's more mathematical. Do you know what I mean? More logical, more mathematical. Yeah? I don't like the other way, I'm sorry. So if you can write this down, please. I know the other way. You say like 100 centimeters equals 1 meter, blah, 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 blah. But I don't like this way. But I know this is what you learn in high school.
Yeah, that's the way.
It's normal.
We don't know the centi,
Yeah. You don't know the centi is 0.01. Yeah.
And we only call the cm is a unit. We
Yeah.
never
Yes, exactly. It's like meter, centimeter.
Yeah.
There's 2 units, yeah. Got that? Yeah. Okay, so the next one now, I want to convert 0.005 meters squared into centimeters squared. We should get 50. Let's try it. Yeah, we're practicing going backwards. 0.005 meters squared. Now here's the problem. We don't want meters squared, we want centimeters squared. So this is what we do. We say this equals 0.005 meters squared, and we put here a c squared, and we put here a c squared. Yeah? So, this is good, because this is 0.005 over 0.01 squared. And this is actually just that. That is just that, which is what you want. Yeah? Nice trick, yeah? See, this is better. And so, this is 50 cm squared. Much better than high school. Much better way.
Yeah.
Yeah. Problem?
We go and try and look at 1 multiplied 10 was
This is, yeah. That means this. Yeah, it's similar on his. If you have a look here, if I can take that, yeah. So if you see here, you do 0.01 times 0.01, he gets this.
okay.
That, see, you have the 10 there, so it just means this, which means, oh, well, I can't switch it. It means this 0.0001. Yeah, 4 zeros. Right, you wrote this down, Ben?
Yeah.
You wrote this down, yeah?
Yeah.
Go? Yep. Okay. Now, normally, when we have like a 2-hour class, like now, usually it's 50 minutes plus 50 minutes, lecture and lecture. But normally for the first class I go a little bit slower because it's the first day. So what we'll do is we have our lecture, plus I'll give you some time to work on the homework, to practice in class now. We can do it together. I can help you. Where's my book? Yeah, so your homework is going to be, and you can start it now, but I'm telling you, next week when we have 2 hours, we will do 2 new lessons. But usually for the first class, I, go easy, go slowly at the beginning.
No problem.
Don't get stressed,
No stress.
No stress for the first class. Your homework is page 7. So you have 1, 2, 3, 4 questions
Yeah.
to do. So you can see the first question, we did something like question 1 in the lesson. You have to tell me the dimension of the unit. Question 2 is like the example I just did. You have to change millimetre squared into metre squared and centimetre squared in question 2. Then question 3 gets harder, and then question 4 is very hard.
Yeah.
So for the exam, you should be able to do question 1, 2, and 3 for the exam. Question 4 is a bonus question to practice something hard, for fun. Yeah? But 1 and 2 should be okay for you. 3 and 4 might be a little harder. So you can start now, and if you want, you can work together, or you can work by yourself, whatever. But if you work together, my only rule is you use English, no Chinese. Fair? Okay? So no Chinese, only English if you work together. So can you start this now? And whatever you don't finish, you must finish at home. Yeah?
Actually, yesterday I tried.
Oh, you did? And how much could you do?
I don't know for how to. I looked the answer, but I don't know why.
No problem. Now, when you did these, when you did number 2, did you do it your way or my way?
My way.
Okay, so can you do it again,
Okay.
but do it my way?
Okay.
Yeah? Okay, so you can do number 2 now then.
Yeah.
Let me close this.